All right, start recording. All right, so I get my pen. Uh-oh, what's that? There we go. Oh my. What did I just do? I'm touching all kinds of stuff. There we go. And let's get the pen ready to go. You guys like the white color, so we'll use white. Okay. So the last thing that we did was the perfect square. Is that right? We did difference of two squares. We did a perfect square. And now we got two more to do. They're very, very similar to each other, these two. So it is the sum of two cubes and the difference of two cubes. The sum of two cubes. Now we had a thing called the difference of two squares, but this is the sum. So what is sum? It's the answer to a what? An addition problem. So sum means plus, all right? And then difference obviously means subtraction, like we talked about before. So here's what it looks like. The sum of two cubes. That means two things are being cubed, and then they're being added together. And there's a way to factor this. It's really hard to try to just, without this little formula, I guess you want to call it, it's really hard to factor a sum of two cubes if you don't know this formula. So this little formula right here is very, very important for you to understand. So here's how I set it up. This is how I think of it. It's two things being multiplied together. Remember, we're finding the factors of this. What is being multiplied to get to this? Right? Well, these two parentheses right there are being multiplied to get to this. The first one's a little smaller because I only have two things in it. The second one's a little bit bigger because I'm going to put three things in it. Okay, can you remember that? Right? Jot that down. So you got two parentheses. One's got two things in it. One's got three things in it. Now let's put the signs in first. Okay, all I'm doing is showing you the formula. I'm not showing you how they got it or anything like that. Okay, all I'm doing is showing you the little formula. So here's a little thing that I remember. I just kind of made this up. It's not that creative, but anyway. I think of the signs as this. I think of same right there. There's two things in there, so there's only one sign. And then I think opposite, and then I think positive. If you can remember that, SOP. All right, same, opposite, positive. What does that mean? It means this right here. It means the same sign as what's right there. So what sign am I going to put in between here? Right, I'm going to put plus. What sign am I going to put right here? Minus, because it's opposite whatever this sign is. And this sign right here is always going to be what? Positive. All right, that's how I started off. Everybody with me on that? Same, opposite, positive. I put the same sign, the opposite sign, and then the positive sign. The same is going to be true when I have the difference of two cubes. So if I have the difference of two cubes, what is this sign going to be? It's going to be minus because it's the same as the difference, right? This will be plus, and this will be plus. So if you can remember same, opposite, positive, I don't know why, that's just how I remember it. Now, what in the world goes in here? Well, it's kind of easy at first. Do you see the x right here? What's being cubed? The x and the a. So that means I'm going to put an x right here. I'm going to put an a right there. All I'm showing you is the formula to how to factor a sum of two cubes. And then what I do is this. This is kind of the same, but if I multiply these together, x times what is x cubed? X squared. So I'm going to put an x squared. And then when I do that last one, I've got an a times what is a cubed? A squared. So I'm going to put an x squared there and an a squared there. Now, to find the term that's in the middle, all I do is take those two terms, the x and the a, and multiply them together. I could put xa, but I kind of like alphabetical order, so I'm going to put ax. That's your formula right there. And let's put a box around it. Oh my. Let me change that to that. There we go. All right, so there's our little formula for the sum of two cubes. I'll show you how to do we'll do an example on this in a little bit, okay? But that's your basic formula. Now, the difference of two cubes is the same thing, except the signs are just a little bit different, but it's still same, opposite, positive. All right, so let's write this down. So let's write the difference. I'll just put diff of two cubes. All right, So what's that going to look like? Instead of x cubed plus a cubed, what's it going to be? X cubed what? Somebody talk to me. Minus a cubed. Okay, so this is the difference of two cubes. It's very, very similar. The only thing that's different are the signs. That's the only thing that's different. But if you can remember same, opposite, positive, then it shouldn't be so bad. So what's the sign in the first one? It's the same sign as this right here. So what's this sign? This is minus, so what's going to go in here? Same sign, same sign. Okay, so it's the same, and then it's the opposite. So we put a plus here, and then the third one's always going to be positive. I don't know, that's, to me, instead of just sitting there and memorizing this whole thing, I just take it in little steps, and I think it's a little easier to understand if you just take it little bit by little bit. Put your parentheses there, put your signs there, and then start chucking in our numbers. So just like up here, what goes here and here? That's an X, and that's an A. Let's do the two outside ones on the next parentheses. But this is going to be x squared, because I'm going to eventually multiply x times x squared to get x cubed. So that's got to be an x squared. Same thing there. That's got to be an a squared. And how do I find the middle? Just multiply those two things together, and that's just ax. And there you go. All right. So there's your two formulas right there. Remember what I said yesterday? These are special factoring type problems. Okay, these are ones that you should recognize. You should look at it and say, oh, that's a sum of two cubes. That's my formula that I use for the sum of two cubes. And you're going to have to memorize this. I will not give this to you. I'm not going to give you a sheet of paper with all these special things on there. These are things that you've got to practice and you've got to know. If you see a problem like this, where you see a difference and then these two things are being cubed, you're like, oh, that's a difference of two cubes. I'm going to use this formula for a difference of two cubes. So everything that we're doing right now are special factoring problems. The next lesson we're going to do is just kind of like, quote, normal factoring, I guess. A lot of math books would start with that and then eventually get to this. But this book decides to start with the special ones first and then get to the, quote, regular type of ones. You're like, Mr. Hamrick, I still don't know what you're talking about. Okay, I get how to set it up, but how in the world do you do these problems? Well, since we just talked about that, let's find one like that. And let me find a good one. All right, let's do this one. This is pretty easy. Well, as far as this kind of problem, this is pretty easy. That's a 3. So that's x cubed plus 8. And the question is to factor it. We want to find what times what is equal to x cubed plus 8. Well, we got to recognize it. So take a look at it. This thing's being cubed. Is something being cubed to give you 8? 2 is. That's right. You got to recognize it. 2 cubed. And that's important. That's what's really important about this. So we already know that x is being cubed here, but what's being cubed to give you 8? A 2. So that's 2 cubed. So this is like the x in the formula. This is like the a in the formula. So we write the formula out. I'll give you a chance. Give you 15 seconds. Ready, go. Write the formula out with the. Don't put the letters and numbers in just yet, but put the parentheses in the plus and minuses. All right? So everybody do that real quick. Remember, it's same, opposite, positive. So you put your two parentheses. The first sign is the same sign. The same sign is what? Well, the same sign is this. So it's the same sign, which is plus. The second sign right here is opposite. So what's opposite of positive? Negative. And then the third one is always going to be positive. So that third one's always going to be plus. And now we just got to stick the stuff in here. So remember we put an x here and an a here. So what is our x? What's being cubed in this first thing right here? It's x, right, just like it was in the formula. Well, what's being cubed right here? A 2. So we put a 2 here. Don't put an 8 there. You put what is being cubed. So a 2 is being cubed, so you put a 2 right there. Pretty easy, right? What goes here? X squared, right. And then I always do the ends first, then I'll do the middle one. And so what goes over here? 2 squared, that's right. And if you can do that in your head, I'm sure, but I'll put it there just so that you see what we're doing. You see that? That's the x squared, that's the a squared. Now what goes in here? What do? Right, we multiply the x and the a, or the 2 and the x. And I always put the number first, and then an x. And that's basically it, except for this. I would simplify that. Instead of 2 squared, what would you put? 4. And that is factored. All you got to do is just plug it into a formula. You got to recognize it first. Recognize that this is a sum of 2 cubes. All right? That's what you have to do. I mean, that's the part. That's probably the hardest part, is just recognizing that it is a sum of 2 cubes. And what's being cubed here? Well, 2 is being cubed. Bryce, you have your hand up? You got it? Okay. Let's do another one. And then we'll do some of those that we did yesterday. All right, this is just about as easy, or maybe even easier. So x cubed minus 1. We have to factor this. When we say we factor it, what are we trying to do? We're trying to find what times what is equal to x cubed minus 1. Now, if you wanted to, I'm not going to right now. If I had more time, I probably would, but I got a few more of these to get through. But if you actually did distributive property and distributed out, right, take the x times x squared times negative 2x times 4, then take the 2 times x squared minus 2x plus 4. If you do that and work it all out and simplify it, guess what it's going to come out to be? It's going to come out to be this whole thing right there, x cubed plus 8. So you could try that on your own. All right, I'm just a little short on time. I'm just trying to keep an eye on the clock. If we have time, maybe we'll go back and we'll multiply it through just to make sure that it is equal to x cubed plus 8, and it will be. All right, let's do this one. This is not a sum of 2 cubes. This is a difference of 2 cubes. There is something that's being cubed right here. That's the x. What about the 1? What's being cubed to give you 1? What is it? 1 is. That's right, because what's 1 cubed? It's 1. That's right. So really, you could think of it as 1 cubed if you wanted to. All right, so is this a difference of 2 cubes? Absolutely. You're cubing the x and you're cubing the 1. So it's a difference of 2 cubes. So I put my parentheses. I put my signs. Same, opposite, positive. This time, it's a minus sign. So what goes here? Minus, and then a plus, because that's opposite. And then this one's always going to be plus. That's not too hard to remember, is it? Same, opposite, positive. All right, let's stick the stuff in here. So x is being cubed, 1's being cubed. Now you take that x and what do you do to it in here? Square it. What do you do to the 1 right here? Square it. What's 1 squared? It's just 1. So we just keep it like that. Now what do we do to the middle one? Just multiply them together. It's 1 times x, which is just x. That is how you do it. Yes? No, it would not be wrong. If you put 1x right here, that would be fine. If you put 1 squared, it would be, it wouldn't be wrong, okay? But we always try to simplify it, all right? You always try to make it look as simple as it can. There's no reason to put a 1 in front of it. There's no reason to put a 1 squared there, okay? It would still be right. I'd still give you full credit for it. But, you just want to simplify it, make it look as nice as possible. What do you think? That's not so bad, is it? Did you guys do this in Algebra 2? I don't know if you did. Can't remember. It's been 9 years since it's been longer than that, since I've taught Algebra 2. So I can't remember what you had in that book. All right, we're going to go back a little bit. Remember we had the sum of 2 cubes? I'm sorry, I just said the same thing that we just finished doing. The difference of 2 squares, do you remember that? X squared minus a squared. And this is just a quick review from yesterday. If you remember this, 1 is plus, 1 is minus, and you put an x here and a here. You put an x here and an a here. That's the difference of 2 squares. All right? So let's do one. Let's do a difference of 2 squares problem. So here's what they would say. They would say factor. Technically, they say factor completely, all right? But I'm just going to say factor. It's kind of assumed that we factor it completely. So x squared minus 4. First of all, is this a difference of 2 cubes? No. It's a difference, right, because it's a minus of 2 what? What's going on? 2 squared. That's right. 2 squares. So what's being squared here? The x. What's being squared to give you 4? A 2. That's right. So I'm going to rewrite it. I'm going to write x squared minus 2 squared. So now it looks like a difference of 2 squares. Now it looks like this. Do you agree? And now we just stick it into our little formula. I guess you can call it a formula. I don't know if it's really a formula or not. But I always like to put a plus and a minus. Put the x here and the x here. And what's being squared? A 2. So you put a 2 here and a 2 here. And that's it. It's factored. You can't do anything else with that. And that's your answer. So this special factoring stuff's not so bad, is it? Let's do another one. Let's do this. So again, it says factor. And I've got x to the 4th minus 16. You got to recognize, remember, these are all special ones right now. We're eventually going to learn how to do some normal, regular ones, I guess. I don't know if they call them that, but we'll do some regular ones later. But you got to recognize that this is a difference of 2 squares. So what is being squared to give you x to the 4th? X squared is, that's right. So x squared is being squared. Do you agree? So that's what you have to recognize. There's not a difference of 2/4 or, whatever. But that's what's happening. So x squared is being squared. What's being squared to give you 16? That's the easy one. 4. 4 squared. So that one's pretty easy, the 16, right? The x to the 4th sometimes can be a little bit confusing. So now what we're going to do is we're just going to factor it, put it into our little difference of 2 squares formula. I like to put a plus and a minus. What's being squared to give you x to the 4th? X squared. So you put an x squared here and an x squared here. What's being squared to give you 16? A 4. So you put a 4 here and a 4 here. Now, it does say factor. Technically, that would be factored, but this does say factor completely. Is this factored completely? It kind of looks like it is. Why not, Matt? Still simplify what? Which one? The squared and the 4. That's got a squared and a 4. Can we simplify this? Can you? Do we have a sum of 2 squares formula? Do we? By me asking you that question, that kind of gives you a hint. Do we have a? We don't have a sum of 2 squares. Okay? We don't have a sum of 2 squares. But we do have a what? A difference of 2 squares. Okay? So this cannot be factored anymore. Okay? You can't factor this. There's nothing where you could put this times this is x squared plus 4. It's already simplified. But you can factor this thing right here. This is a difference of 2 squares. So it's kind of like difference of 2 squares in one problem. Everybody see that? So this you have to recognize is not completely factored just yet. You can't do anything with this one, so I'm going to keep it like this. All right, and now what we're going to do, this is a difference of 2 squares, so I'm going to take this and apply it. See, because you're squaring something to get x squared and you're squaring something to get 4. We just did something very similar to this before. Okay, so plus and minus, x and x. And what's here and here? 2, right, because 2 squared, right? 2 squared is being 4. Now is it simplified? Yes, it is. All right, and that's your answer. So that was a little bit trickier because usually you do one step and you're done. All right, but the higher up in math you go, it's rare that you do one step and you're done the problem. Okay, it's step after step after step. Okay, when you get into higher math stuff, and this is just one example of just the second step that we have to do. You got to recognize that this right here is not completely factored. All right, so you got to factor it some more. That's why it says factor completely and not just factor. So on a quiz or a test, I'll put that word completely in there. Okay. All right. You can't. Try it. I'm going to put a big question mark here, okay, because you can't. But I'll just show you why. And that's a good, I mean, it's a good observation. It's a good guess to say, oh, x plus 2 plus x plus times x plus 2 is x squared plus 4. Is it? Let's do the FOIL on this. That's right. X squared plus 2x plus 2x is plus 4x plus 4. So this right here does not equal this. Okay, so you can't simplify x squared plus 4. Again, remember, there is no sum of two squares. There is a difference of two squares. Okay, but there's no sum of two squares. But there is a sum of two cubes, right? We did that just a few minutes ago. But there is no sum of two squares. Good question. Anybody else on this before we go to another problem? Got like 10 minutes. I think we've done all of those. Let's go, we're going back in time a little bit more. This is still from yesterday, but this is one of the first, but one of the first things we talked about yesterday. And it's a perfect square. Do you remember perfect square? Talking about that? So, for instance, if you have like x plus 2 squared, okay, that's a perfect square because you have one thing in the parentheses and it's squared. But what would this be? We just did this, right? We did this like 5 seconds ago, right? So it's going to be x squared plus what? 2x plus 2x, which is 4x, right? Plus what? 4. So what we're going to do right here is I'm going to give you this, and you have to come up with that. That's what we're doing. You understand that? Because it's factoring. So we want to find out what times something is equal to x squared plus 4x plus 4. Well, x plus 2 times x plus 2 is equal to this, right? Or x plus 2, the quantity, that whole quantity is being squared. So let's take a look at this problem right here. Now, again, technically it says factor completely. I just don't want to write the word completely, all right, because I'm too lazy. So it's x squared plus 6x plus 9. What we need to do is we need to factor this. First of all, we have to figure out, is it a perfect square? So what do you think it would be? What are you squaring to get x squared? An x. What are you squaring to get a 9? A 3. Let's see if that works. All right, so let's go x plus 3. If you remember the little formula for a perfect square, do you remember what the middle term was? I don't have it written down. I mean, I guess we could write it down. Let me just write down the formula for a perfect square. We'll do it over here. So x plus a squared, right. And that's x squared plus 2ax plus a squared. That's the formula. Okay, right there. Okay, so does this fit? Okay, what are you squaring to get to this? You're squaring 3, right? So if I go 3 times x and then double it, what is that? That's 6x, isn't it? So is it a perfect square? Yeah, it is. Here's another way to check. They don't say this in this lesson, but eventually you'll see this, okay? And I'll show it to you some other time. But watch, if I take half of this, we're going to go opposite. We're not going to go this times 2. We're going to take half of this. So what's half of 6? 3. And if we square it, square 3, what do we get? 9. If you can do that with this trinomial, then it's a perfect square. You follow me on that? We're going to use that trick with something else later on. But right now, if I take half of this, right, which is 3, and I square it, and it's 9, that means it's a perfect square. So then I can just write it just like this. You okay with that? Let's do another one. That one's, well, I guess we better do it because we're running out of time. So let's do this one. So we're going to factor 9x squared minus 6x plus 1. Now that little trick I just showed you is not going to work on this one. But let's just see. Let's just take let's just take a guess and then see if it works. Okay. First of all, is this a perfect square? Well, are you squaring something to get to this? You're not. You're squaring a 3, right? And you're squaring an x. Are you squaring something to get to 1? Yes? No? What do you think? Yeah, you're squaring 1, right? We talked about that earlier. Sure. Okay. Let's just try it and see if it works. So I'm going to do this. So what are you squaring to get 9x squared? 3x. Okay. And we always put a minus in here for this. Well, whatever that sign is, that's always going to be that sign right there. And then we put a 1. So that looks like it would work, but let's just try it and see if it works, okay? Let's just test it and see if this is this right here. Well, let's do some FOIL. 3x times 3x, 9x squared. The outside is minus 3x, the inside is minus 3x, and the last is plus 1. Does it work? Sure does. It's the exact same thing, isn't it? So, is this the factors of this? Absolutely. If you wanted to write it down like this and put them separate, it's fine. You can do that. I wouldn't mark it wrong at all. You get full credit. But it's a lot easier just writing it like this. These are probably a little bit more difficult. Okay, that's why they left them to the end. All right, you can go back on it and look, okay? Watch the video again if you need to, just that little part of it, if that's what you need to do. We're going to do one more, and then that will be it for today. And I'll give you a homework assignment. So it's 25x squared plus 30x plus 9. Here's another way you could do it as well. So what is being squared to give you 25x squared? 5x. So I'm going to just do this a little different than I did the other one. What's being squared to give you 9? 3. Now remember, how do I know if it's a perfect square or not? I can take the a, or the x part and the a part, multiply them together and double it, and it should equal this. Does it? 5x times 3 is what? 15x. Does 15x doubled? What's that? 30x. Okay, is it a perfect square? Yes, it is a perfect square. Let's do that test to the problem we did before. Right here. What's being squared here? A 3, right? And what's being squared here? A 1. 3 times 1 is 3. Double it, it's 6. Is it a perfect square? Yep. You see the test on it? All right, that's how you test it. All right, so now what we're going to do, now's the easy part. Once you recognize it's a perfect square, we can just do this. Look, you got a plus sign here, so the plus sign is going to be right there. What's being squared? 5x. What's being squared? 3, and that's your answer. So if you can recognize that it's a perfect square, it's not hard to do. It's just recognizing that it's a perfect square is the hardest part of this. Peyton. Just in your head? Yeah, like yeah, on these kind right here, you could just go from here to here and I'd be fine. Okay? And you're right, because a lot of these you could just do in your head. You could just look at it and write it down. You can check it if you want to, but I'm not going to make you do it. Okay? If you want to, that's perfectly fine, but I'm not going to make you do that. All right, here's your homework. And please, I'm still getting people that are not doing this. Now, most of you are, okay? But this is how I want you to write this on your paper. So the very first thing, put your name on it and then put this. And it's part 1. Part 1. So I want to see this on your homework because that's what I put. When I put it in my grade book, I put this. I don't put the page numbers and problem numbers, okay? So I recognize the homework by this. Then you can go ahead and put the page numbers and all that. Actually, it's just one page. So it's page 56, and we are doing 5 to 37 odd. That's your homework right there. Okay? Please write this down. Write all this down on your homework. At the top somewhere, put section R5, part 1, because we're going to have a part 2 and a part 3. So make sure you put part 1, put the page number and the problems, make sure you have your name on it, and then you should be good to go. All right? Okay, that's it.